yeah, I just want to spend a little bit of time on this slide. So what we're seeing here is, here is the schematic symbols, the simplified symbols on top, and the schematic symbols on the bottom. If you look at the thread in this call out from the round view of the hole, looks the same. When you look at that same thing through a hidden view, the schematic and simplified look the same. But when you look at it through a section view, here's where you see the difference between the simplified and the schematic. Okay, so here we have another like hidden view here, and then here we have a section view. And the section view, you can tell the difference between the simplified and the schematic. That's what that slide does. Next is detailed representation. This shows you how to draw the detailed representation if you were doing it by hand. It actually shows it how it is actually depicted. This is the detailed representation for a square thread, and how to do that. Again, you probably won't be doing this because we usually use CAD. So now, here is the national standard for pipe threads. So pipe threads, look, the pipe threads that you would have like on pipe fittings or pipes. So pipes are threaded. They have actually have a tapered thread. So this would be this part of it is the thread on the pipe. You can see it's actually tapered. Now, how you keep threads from leaking on these is typically you would tighten them up, and then they would typically use a pipe dope or something like that, or Teflon tape or something to seal the threads. But these pipe threads are tapered, and as you tighten it up, it gets tighter and tighter. So that's a tapered profile of a pipe thread. Let's talk about tapped holes. Typically, a twist drill has a 118 degree point, so that leaves like a 31 degree on both sides. When you're dimensioning a drill to a depth, it's to the full hole size. That's to the edge of the point and not to the bottom of the point. And then they also say in this slide, it says the thread length is the length of the full or perfect threads. So when you specify thread length, those are perfect threads. And what they're also talking about is you have to leave some room down in the bottom of that hole. So the bottom of the hole here, because most taps have a big lead in on them, and in which case you can't really get threads to the bottom of the hole. That's why people will use a thread relief. Okay, and what they'll do is they'll take the tap and typically, grind off the end of a standard tap to get that threads as deep as they need them to. So let's talk about bolts, studs, and screws. So this is a bolt. The term bolt is generally used for denote through bolt. It has a head on one end. You put it through some clearance holes, and then you tighten it up with a nut on the other side. When we talk about a cap screw, generally think about something like a bolt, but it threads into another member and is not held together with a nut. And over here we have a stud. So the stud is like threaded into this body here, and then it has another thread on the other end, and then it's used for holding these two pieces together. Screw heads. This just gives you a basic idea of the different types of screw heads that are out there. The Philister has a pretty wide body. Pan heads versus an indexed head slotting. I'm just telling you what kind of threads are out there, what kind of fasteners are out there, and what kind of screw heads available. So drawing a standard bolt, these would be the dimensions you would need to draw a standard bolt in the construction thereof. Okay, so the length of the bolt is from the underneath the head to the end. Here we're drawn with the schematic threads, and then it tells what the dimensions are. So the distance across the flat would be 1.5, the D dimension. So And it shows all the proportions here. Okay, lock nuts. Locking devices. These would be just devices to keep your screws from loosening on you in service. A lot of machinery has vibrations and stuff like that would cause threaded fasteners to loosen up, so therefore there's ways of locking them. You've seen these before. This would be called like a jam nut. Okay, so you torque this bolt and then you torque this bolt against the other one, and that holds it in place. In this case, we have a split lock washer. The split lock washer, it gets placed underneath the head of the nut, and what that does when you tighten it down, it takes a certain amount of force to compress that lock washer, and that force will hold the bolts, the threads tight. In this case, we've got a set screw or a pin coming through the side of it that keeps it from loosening. Here we're using a cotter pin. Here we're using a set screw through the side of the nut, and you tighten that up, it bears against the bolt, and keeps you from loosening. And then here we have another cotter pin with a castellated nut arrangement, and here's yet another castellated nut arrangement. This has like a feature in there. Typically what these will have like an insert in there, like a plastic insert, and that plastic insert, as you thread the nut onto the bolt, it cuts threads in the insert, and that helps to lock it. And then this is a washer that when you put the bolt on, you tighten it up, you bend these tabs up on the tab washer, and that keeps it locked. Here's the one that's held with a retaining clip, and then here's another one with a it kind of looks like a set screw arrangement. So the whole point here is you want your threaded fasteners to stay together. Let's talk about cap screws. So these are your standard type of cap screws. There's a hex head cap screw, there's a flat head, a round head cap screw, a philister head, and then a socket head. When I say socket head, that's that internal wrenching feature up here is the socket. And then machine screws are similar to cap screws, but they're about smaller. We're going to talk about that in class a little bit. And then there's set screws. Set screws have the entire body is threaded. They typically have a socket in them. And then here's how you would define it: the size, the thread, and then the length, and then what kind of end point. And there's all kinds of different end points that are available for set screws. Here's a depiction of wood, your typical wood screws, and their dimensions and how they're drawn. Here are some miscellaneous nuts and bolts. These are just the different kind of things that you can come across as a designer. And then finally, machine pins and rivets. So in this case, we have a tapered pin. The tapered pin is set into a tapered hole, and it's used to lock features in place. Tapered pins are used all the time in aerospace to hold things together. And then we're going to talk about rivets a little bit. But you know what? I'm not going to talk too much about rivets because there's a lot of information on rivets out there. But nowadays, rivets aren't used very much with all of the advances in threaded fasteners and stuff. We really don't use rivets. Where we do use rivets is when you don't have enough space for a fastener. I mean, I rarely see rivets anymore in aerospace, except when I'm running out of room and I really need something low profile to hold a couple parts together. So I'm really not going to talk too much about rivets, and this concludes the presentations for Lesson 6. Thank you.